afternoon, and good evening, depending on where you're connecting from. My name is Sagnik Datta, and I'm part of the Citrix Ready technical marketing team managing the desktop ecosystem. I would be your host today for today's webinar, where we have EMC XtremIO with us. So let me welcome you all to the Citrix Ready technical webinar series, where we showcase how Citrix and our partners have integrated to deliver valuable products and solutions to common problems faced by our customers. Along with me, I have the main speaker, XenDesktop Mandal, who is the Solutions Marketing Director at EMC. Moving on, could you change the next slides, please? So Citrix Ready is a end-to-end technology partner program that showcases and recommends third-party products, solutions, and services that demonstrate compatibility with Citrix products. Customers can quickly and easily navigate and find solutions recommended by Citrix in the Citrix Ready marketplace. Just navigate to the first link here, citrix.com/ready. And if you're interested to be a partner and are interested about our program, you can navigate to the second link, which is partnerprogram/Citrix Ready. Moving on, could we go to the next slide? Just a little bit of history here. Citrix Ready program was launched in the year 2007 and has currently more than 1,000 technology partners with over 27,000 product verifications. We have over 2 million online catalog page views. So moving on to the next slide, let me just talk briefly about EMC. So EMC was established in 1979. It is a veteran in our storage solution space, over 70,000 employees currently working, and been partner with Citrix since 1990s. Today, we will hear about how EMC XtremIO all-flash array consolidates your mission-critical application landscapes, eliminating storage sprawl, and delivering the agile data center. Far more than just performance, it unlocks your competitive agility with real analytics and development, infrastructure agility with elastic provisioning for performance and capacity, and reduced TCO with 50% lower CapEx and OpEx that doubles the storage life cycle. XtremIO enables this with its unique scale-out architecture and inline always-on deduplication, compression, thin provisioning encryption, and in-memory space-efficient copy services. Storage is no longer the bottleneck, but basically an enabler for transformational workloads like real-time analytics, database lifecycle acceleration, SAP landscape consolidation, private hybrid clouds, enterprise-wide VDI, messaging and collaboration, and future-proofed healthcare EMR. So I'll be rolling the dice to our speaker now, but before that, please note, if you have any questions during the webinar, please use the question panel on the right-hand side, and we will take your questions at the end of the presentation in our Q&A session. All right. Please welcome our speaker, XenDesktop Mandal, Solutions Marketing Director at EMC. Hey XenDesktop, I welcome you to this technical webinar series, and over to you.
Thanks, Sagnik. The agenda for the rest of the session is as follows. First, we are going to take a look at why the combined forces of Citrix and XtremIO provide you the best options for your desktop virtualization needs, followed by XtremIO design fundamentals for VDI. Next, we are going to dig deeper with XenDesktop image management options and their impact to storage, complete with XtremIO's unique XenDesktop integration, demonstrations, and customer case studies. At the end, we will put it all together to conclude and take questions. Did you know that 43% of the workforce uses 3 or more devices for work today? That's really probably not surprising if we look at our own work habits. It really isn't about having lots of devices though. It is about the diversity of apps and consumerization and the expectations of users. We expect self-service, simplicity, flexibility, and easy collaboration. Today's IT has to have the ability to centralize, virtualize, and deliver apps, desktops, and data with greater control, security, and efficiency, and ultimately lowering costs. Any data center today is really a delivery center now where all aspects of computing are becoming cloud-based services. Citrix XenDesktop is a suite of desktop virtualization products. It gives employees the freedom to work from anywhere while cutting IT costs. The industry-leading Xen app is built in, and XenDesktop can deliver full desktops or just apps to any device, allowing you to choose the right delivery model for the right user at the right time. This reduces costs and extends the benefits of desktop and app virtualization to the most users. Now, Citrix is the clear leader in the desktop virtualization market. As you see here, IDC puts Citrix at the top right corner in the leader category for the client virtualization software market. Other analyst reports as well as market share data establish Citrix as the topmost vendor for desktop virtualization software. Now, we have been talking about desktop virtualization software so far. The underlying infrastructure and more specifically the storage platform plays a critical role in the success of any desktop virtualization deployment. User experience is the single most important metric that determines success or failure of your desktop virtualization project. Nobody wants to give up their laptop experience that they are accustomed to. Now, in a hosted VDI model, you centralize all of your user desktops, traditionally running on standalone PCs or laptops, into a data center. It means moving from consumer-grade storage to costly enterprise-grade storage for hundreds or thousands of users. To offset the associated huge capital expenditure, organizations typically trade off between cost and user experience. For example, giving users desktops that cannot be personalized, or trying out various storage optimization techniques that more often than not fail to work, especially at scale. Speaking of scale, I see organizations piloting VDI with, say, 100 to 250 desktops. Now, any storage array, especially flash-based ones, can do small number of desktops at proof of concept level with most of the array being empty. But as you roll into production and increase the number of desktops, as the array capacity starts getting utilized, that's when you start discovering major headaches. Moreover, beyond the performance and capacity discussions, what about the other aspects of VDI solution? For example, user data, backup, HA, DR. XtemIO all-flash array is a unique, differentiated breakthrough product that transforms VDI into a viable business strategy. It is the fundamental enabler on the transformative possibilities of desktop virtualization. How? Let's take a look. Now, before we delve into specifics of XtemIO for desktop virtualization, let's spend a minute reviewing XtemIO's impact on the market. We started shipping the product at the end of 2013, and within these 18 months, XtemIO has become the leading all-flash array by every measure, including market share and the Gartner Magic Quadrant. Customers have adopted XtemIO more rapidly than any storage platform in history. over 1 billion revenue run rate achieved in our very first year with over 1,700 unique customers today, including 40% of the Fortune 100 and Fortune 200. And most important of all, this huge customer base has experienced well over 5 nines of reliability, now trending towards 6 nines actually, showing XtemIO is ready for all mission critical workloads, including desktop virtualization. As the slide builds in, XtemIO's architectural advantages translate into very significant savings for our desktop virtualization customers. Today, we have over 2.5 million virtual desktops running on XtemIO, and our customers typically see 10:1 or more data reduction ratios for persistent or static desktops with 50% less cost per desktop than traditional storage. A single X brick, which is the basic building block of XtemIO cluster with 2 storage controllers and a disk array enclosure, typically called DAE, that can have up to 25 SSDs, can host up to 2,500 persistent or static desktops and up to 3,500 non-persistent or dynamic desktops. I want to add that beyond storage, XtemIO helps in reducing server infrastructure footprint as well. As an example, we have had customers who could reduce RAM allocation from 2 gig per desktop to 1.5 gig per desktop. Now, that's a 25% reduction in RAM, and XtemIO handled the resulting increased IOPS due to more swapping by the OS with the same latency for the same number of desktops hosted on the array. So Citrix and XtemIO together provides the best solution for your desktop virtualization. Here you have the market leader of desktop virtualization software joining forces with the market leader of flash-based arrays. Together, we can scale from hundreds to hundreds of thousands of desktops, delivering uncompromising end-user experience at scale all the time for all user types. With XtemIO, you have admins that have a radically simple storage management experience where they can provision desktops really fast on demand as you scale. The net result for you is very low dollar per desktop and better than physical desktop for performance, user experience, and most importantly, economics. What's unique about XtemIO that makes it best storage platform to deliver unparalleled user experience while maintaining a radically simple admin experience with the best dollar per desktop for every desktop virtualization use case? Again, let's take a look. When you think about Flash, the first thing that jumps to mind is speed. To be really fast with some added data reduction is also the thing that so many other storage vendors try to solve. We take being fast and having data reduction capabilities as table stakes, as granted. So we are focused on being the smartest array as well by intelligently solving the requirements of modern applications in a modern data center. For example, delivering high performance with consistently low latency for hugely random workloads in virtualized data centers. Think of the IO blender effect. Again, efficiently managing copy data. Say, think of database copies for dev, test, analytics, backup, etc. Cloning hundreds or thousands of VMs in a private cloud setting or for desktop virtualization. And delivering application agility in an environment complete with constant resource utilization balancing. Think vMotion, live migration, storage vMotion, DRS, all those things. Now, XtremIO's clean sheet design with innovative use of flash technologies for its unique true NOA active-active scale-out architecture, advanced inline all-the-time data services, unique copy data management coupled with automated self-service workflows for application administrators enable organizations to not only improve their infrastructure and application agility, but also transform their businesses. We are going to take a peek at all these 4 architectural pillars, including special integration with XenDesktop for VDI environments. Moving on, as I mentioned earlier, Xbrick is the basic building block of XtremIO cluster. It has 2 controllers and a DAE that can have 25 SSDs. These Xbricks come in sizes ranging from our starter 5 TB Xbricks and full Xbricks of size 10 TB, 20 TB, or 40 TB. You can keep adding these Xbricks non-disruptively in a cluster. So you can start small and grow as you need without any service disruption as your VDI needs grow in a very, very cost-effective way. Most importantly, each of these Xbricks supports up to 150K mixed IOPS and up to 250K read IOPS. With everything, with all the data services always on, no matter how large you scale the cluster. And XtremIO scales linearly for both capacity and performance. With 8 Xbricks, that is 16 active-active nodes, XtremIO can scale up to 2 million read IOPS while maintaining sub-millisecond latency. This gives XtremIO the ability to handle not only any VDI workload at scale, but also consolidation of your other tier 1 workloads like databases and virtual servers. Now, what makes XtremIO unique for VDI? In a nutshell, XtremIO's unique content-based in-memory metadata engine coupled with its scale-out architecture delivers the unique value for VDI. You grow an XtremIO cluster by non-disruptively scaling additional Xbricks, linearly increasing both capacity and performance at the same time. The volumes are always thin provisioned. The only writes performed to the disks are for the data that are globally unique across the entire cluster. Now, all the data services, including deduplication, are inline all the time. What does it mean? VDI environments are usually write-heavy with significant duplicate data blocks. Our deduplication is global across the entire XtremIO cluster, irrespective of the number of Xbricks you have in a cluster. For VDI, it means we only write unique data to the SSDs, data that the entire cluster didn't see in its entire I/O history. And it is inline. As the writes come in, our intelligent metadata engine looks at the content of the incoming data block at the memory level, performing the writes to the SSDs only if the cluster didn't see the data before. Now, if the data is duplicate, it just acknowledges the writes to the host with appropriate updates to in-memory metadata structures and without actually performing any writes to the SSDs, thus completing these writes literally at memory speed. This inline deduplication not only saves tremendous capacity, but also potentially improves performance as well. Following up on the other data services, for example, inline compression adds to XtremIO's data reduction efficiency. XtremIO has proprietary flash-based data protection algorithm that offers better than RAID 10 performance with better than RAID 5 capacity savings. Finally, XtremIO's differentiated agile copy data service helps you provision and deploy desktops at a much faster rate than any other flash-based solutions in the market. We are going to take a look with this specific example. This key area of differentiation, especially for VDI, is how XtremIO does VM cloning with hypervisor copy offload primitives like VAAI copy offload or Xcopy for VMware, ODX for Hyper-V Windows Server. Today, every storage vendor supports this copy offload primitives for hypervisor. It's literally a checkbox that any vendor needs to satisfy to be taken seriously. But underneath, they have to do a brute force copy to clone the VM. So while this is better than copying at the hypervisor level over the network, it is slow and space inefficient process. With XtremIO, it's all different. As XtremIO doesn't store any duplicate data globally across the cluster, and the deduplication happens inline and in memory, the copy operation in XtremIO is super fast. At RAM speed, it doesn't consume any extra space, and the host sees effective throughput higher than the physical bandwidth available. Okay? So this fast cloning has nothing to do with the SSD drives themselves. It is because how we manage copies with the metadata pointers in the system, all stored in RAM. So our cloning is at memory speed as opposed to SSD speed. With all these technical innovations, it's important not to lose sight of the most powerful benefits of XtremIO, that is radical simplicity. It's truly as easy as 1, 2, 3 to configure and deploy and tune all the workloads you want to throw at it. Literally, there are 3 steps. You create the volume, any number of any size you want, then create the initiator groups for all the hosts and their applications, and map the volumes to those initiator groups. That's it. No tuning, nothing else. As an admin, you get your life back. With these XtremIO fundamentals in place, let's take a look at the specifics of XenDesktop with XtremIO. So let's go over some of the VDI desktop models that we find today. Dedicated desktops, sometimes also referred as persistent desktops or full clone desktops, are pretty simple in concept. You take everything you have in your physical desktop, OS, applications, user settings, and just make it a VM running in a data center. They retain user personalization, but are typically associated with higher storage capacity requirements and costs. This is just not the case with XtremIO's high performance, in-memory metadata, and always enabled inline deduplication, because a lot of the data from OS and applications are common across all the full clones that you deploy. In fact, many of our customers run XenDesktop with dedicated full clone desktops, and we have developed special XenDesktop plugins to enable this specific use case. Next, the pool desktops, also known as non-persistent desktops or linked clone desktops. Here, all desktops share the same read-only base image, and the individual desktop writes destined to the OS get written to an unique differential data for the desktop. This differential data space is called the difference disk or write cache, and the differential data gets discarded when users log off or desktops reboot. So we solve the capacity problem at the expense of user personalization. This type of desktop is commonly deployed for task worker use cases like call centers. Citrix has developed a technology called personal vDisks that delivers the best of both worlds. Here, all the desktops share the same base image, but user settings, profiles, user installed applications, all those things get stored in the separate personal vDisk of each individual user, thereby retaining user personalization across sessions, reboots, OS and patch updates, all those things. It is a good solution with less storage capacity footprint than traditional dedicated desktop, definitely. But it does add complexity in managing your virtual desktop environment. Xtremio works very well with personal VDIS-based solutions as well. As we discussed in the beginning, XenDesktop 7.x enables a lot of the desktop virtualization use cases. Now, the critical component that defines the robustness needed out of the underlying storage platform is the central image management module. Machine creation services, or MCS, and provisioning services, or PVS, are the two technologies Citrix developed for desktop management. Now, full clones with static builds for dedicated desktops are another option. Together, these options define the high performance with consistently low latency and effective capacity reduction needed out of the underlying storage platform. Let's take a somewhat detailed look at each of these three options. In MCS, the base image is copied to each data store volume. So in addition to the shared base image, each desktop has its own identity disk where the unique things about the desktop like address, etc. are stored, and a different disk where all the writes are stored. You can have both persistent desktops with PP disks as well as dynamic or non-persistent desktops with MCS. All these identity and different disks are stored at the same data store volume coming out of the underlying storage platform here, as you are seeing from XtemIO, for example. MCS typically creates very high performance requirements for the underlying storage platform. Let's see a demo by our field CTO Xtremio, where simultaneously booting 2,500 desktops creates nearly 200,000 IOPS. Okay, as we will see, Xtremio handles this very high load very, very well with low sub-millisecond latency. In fact, all of these 2,500 desktops will be available in approximately 10 minutes with an average boot time of less than 1 second. Okay, so let's roll.
Use case for XtemIO is VDI. In this specific example, we're going to use Citrix and desktop to simulate the bootstorm of 2,500 VDI VMs. What we have here is a single 10 terabyte exploit, but as you can see right now, it doesn't do too much. That's because the VDI VMs are all shut down. As you can see, none of them is registered currently with the DDC servers. That's because they're all down. So what we're going to do now is actually put them all up at the same time and see how it goes. I'm going to select them all, and there you go. And what I'm going to do is I'm going to use this free stopwatch utility, so the moment the DRS will start calculating on which host to actually place the VM that it's going to start booting, and actually start booting the VMs in general storage role, I'm going to start the stopwatch utility itself. So there you go. We just started now, and if we go to the array, we're going to see that we're just starting to fill the apps and the bandwidth right now. So I'm going to resume the recording in about 5 or 6 minutes, where we can actually see VM starting to get logged in, and we're going to examine how long did it take us in general to bootstorm all of these VDI VMs. Okay, let's take a look at what we see after 7 minutes and 40 seconds. You can see roughly 830 VMs. And this number will significantly grow with every refresh that I do at the DDCs, which is what we expect. If we go to the storage array, we can still see that a very high load is taking place. We can see the I/O distribution versus with the block sizes. We can divide it via volumes, although I would expect similar workload on each one of the volumes. That's the beauty of the scale out. Need to balance nothing, the type of architecture of the array itself. If we go back to the Citrix DDC and refresh the screen, we'll see more and more VMs start being logged in. So I'm going to suspend it for a couple of more minutes to see when do we actually have the majority of them being logged in. There you go, after less than 10 minutes, we have more than 2,100 VMs being logged in out of the 2,500, which is amazing, considering all the I/O load that the single 10 terabyte expert needs to sustain. And very, very soon we'll have almost all of them being logged in. We're very, very close to that. Remember, we have 2,500 VDI VMs. And there you go. In 10 minutes and 30 seconds, we have almost all the VM being logged in, which is really amazing. Those would just be log one, which is probably the service that needs to be restarted. And we can actually cross-evident it with the array load itself. As you can see, it's very, very low. So really, if we want to zoom in, that was the bulk of the time when the array was busy during the boot time. So amazing results with XtemIO 4.0, booting up 2,500 Citrix machine creation services VMs.
Moving back. Next comes provisioning services, or PVS. Now, unlike MCS, PVS streams the desktops over the network. The base image is stored on vdisk volume and is read into the surfer RAM when desktop starts booting. The boot I/O need is reduced in comparison with MCS, as the vdisk is cached in RAM and streamed over network. However, as we will see in the next demo, IOPS requirements for desktop booting from PVS is still significantly high. The other part of PVS image management is write cache, where the writes to the OS are stored. The write cache can be stored in RAM with overflow options to disks when RAM is exhausted. The RAM cache with overflow to disk was introduced to PVS starting from XenDesktop 7.1. This is a good option for reduced IOPS needs, definitely much less than MCS, but again, as we would see in the next demo, it still generates significant IOPS for the underlying storage platform. The other options include client disk cache, that is storing this write cache on a desktop drive that is local to it, which is VM's hard drive allocated from data store volume coming from the underlying SAN storage. This is the most prevalent option for the Citrix XenDesktop install base today, and it has significantly higher IOPS requirements. Now onto the demonstration of PVS with RAM cache overflow to disk by exit. As we would see, this is the least IOPS requirement use case for XenDesktop, but still needs the high performance with consistently low latency of XtremIO.
In this video, we're going to examine the new Citrix provisioning services, the cache to RAM with overflow to drive. I want to examine the impact of an all-flash array, in this case, our EMC XtremIO, and as the first, I just examine the environment itself. I've got 3,500 VDI VMs running as provisioning services with Citrix PVS. And if actually over to the PVS console itself, we can see that I configure PVS with a standard image, cache in RAM with overflow to hard disk, but as opposed to using the default 64 meg per VM, I actually gave it more. I gave it 256 megabyte of RAM per VM, so we could probably simulate a more real-world use case. the configuration itself. I've got a couple of PVS servers that are ready to go. Okay, next I'm going to generate a boot form. So in order to do it, I'm just going to go back to my vCenter and select all the PVS VMs that I want to start. In my case, 3,500 VDI VMs. There we go, we're going to start the booting process and see the XtemIO interface in a couple of seconds. Okay, so we can start seeing the I/O climbing up and up and up. That is expected because boot forms is a notoriously I/O killer, if you would like, in terms on the storage itself. It's one of the values of an old-fashioned RAID such as an EMC XtemIO. Going back to the studio server, we can see the VM starting to ramp up slowly but surely, and apps will go up and up and up and up. Okay, so from a storage perspective, the IO storm already been settled, which is actually was quite good. I mean, when you think about PVS provisioning services, it's actually utilizing a network to deliver the VM itself. It's only the right temporary cache that's being stored on the NAS. So this is the part where XtemIO is fairly busy compared to, I guess, nothing. And this is the part that's currently taking place, which is really nothing about the storage itself. The I/O is fairly low. It's just that PVS itself is still busy processing those incoming requests over the network and over its local CPU utilization. Okay, now the boot form is finished. We're going to examine the real user workload using local VSS. So here we have PVS. We're going to publish. We already published VDI VMs to the end users. And now we're going to start running some workload using login VSI. So let's start configure login VSI for the test. Login VSI is now connecting to the launchers, those VMs that will initiate the original connection to those VDI desktops. And for that, the test has now started. So 4 VMs have already been logged on. So let's overthrow those VMs, see what they're actually doing. Let's go for the first one, open its console. So yeah, it's logging into those VMs as we speak. Some of them are launching Microsoft Outlook, some of them are running Microsoft Word. It's only going to use standard applications in the market such as Microsoft Outlook, Microsoft Word, Internet Explorer to browse the internet, Microsoft Excel to sort Excel files, Java-based applications such as FreeMind and even Flash games just to simulate some workload. It's even going to install some movies just in case. And here we can start to measure the IOPS itself. We can already see some IOs going in and out as we scale with more and more users during the login VSI, the login storm part. And we run more IOPS. We just reached the 30,000 IOPS barrier. Latency is also looking good. We're still below 1 millisecond latency, which is really, really good. And more IOPS are coming from. Okay, so as we are approaching the end of the test, and almost 3,300 VMs have been logged in, just want to take a general look, right? So we do see quite a lot of IOPS, even though we use PVS with RAM to with overflow caching to drive it themselves. So that still shows that a lot of IOPS are still required even if you're using PVS, which is absolutely amazing with its new capabilities. But still quite a lot of IOPS are required. So thank you, and hopefully that was enjoyable.
Okay. The last piece for image management is where you have static builds for VMs. These are the dedicated desktops with full clones, essentially taking whatever you have, OS, applications, user settings, user installed applications in your physical desktop today and making it a VM. XtemIO handles this use case very well with its performance and inline data reduction capabilities, as we don't consume any extra capacity unless the data is globally unique. The clones and snapshots with XtemIO are fully based on in-memory metadata and deliver the same performance and data services like the parent volume. As I said earlier, we have built a unique XenDesktop plugin with automated workflows to support this. No other vendor offers this. Let's take a look at how this plugin works. All the steps I show next are automated. This is for explaining what's happening in the backend and how we are delivering this functionality. Step 1. First, this plugin clones a master VM to a data store leveraging XtemIO's unique copy data management technology. The clones do not consume any extra capacity. So I took an example of creating 2,500 dedicated full clone desktops, and I'm starting with a master VM. I clone it in a data store 100 times. Okay. Next step. Then it is taking a snapshot of the parent data store, again, not consuming any extra capacity. Okay. It then syspreps all the VMs in the snapshotted data store. After that, it is repeating these two steps, taking the snapshot, sysprepping the VMs till the total VM count reach the desired numbers. In this case, 2,500 desktops. So when it is done taking snapshots of the data stores and sysprepping the VMs, we now have 25 data stores with 100 VMs each. For the next step, it's going to populate the XenDesktop delivery group with this desktop VMs. So you just created 2,500 full clone dedicated desktops with the actual capacity utilization of the unique data that was there in the original master VM. So if it was 40 gig master VM, right, probably say, as an example, I'm taking even like a bare minimum 2:1 data reduction. So that essentially means like a 20 gig for this 2,500 full clone dedicated desktops created by an automated workflow within a very small window of time. Let's take a look and browse through this XenDesktop plugin user interface so that you can see yourself what input you need to provide to make this magic happen automatically at the back end. First, master image location. Then you provide the clone option, desktop group choice, machine catalog, desktop group name, and that's it. Once you click finish, it will do all the steps I mentioned earlier automatically, and quickly you will have all these dedicated full clone 2,500 desktops available with tremendous capacity savings and high performance of XtemIO. This is a common VDI use case among XtemIO's XenDesktop customers. Now let's put everything together. XtemIO can run non-persistent or full desktops very well. It delivers high performance with consistently low latency, thereby enabling you to host up to 3,500 desktops on a single Xtremio. You can run storage-intensive operations like desktop refresh and recompose in a non-persistent desktop environment while other active desktops are running, and the array will continue to deliver high level of user experience. However, if you are running non-persistent desktops only because of capacity savings you need, then XtemIO has good news for you. The same single Xbrick can host a high number of dedicated full clone desktops as well. Your users can have a highly responsive desktop with all their personalization, and your desktop admins can continue to use the same set of desktop administration tools while enjoying the superior storage capacity reduction from XtemIO to make the solution very, very cost effective. As we saw, high IOPS is a critical need for any VDI deployment, whether you are using PVS RAM cache with disk overflow, MCS, or full clone dedicated desktops. Similar to the demonstration we saw, here XtemIO GUI dashboard is showing that a single Xbrick is delivering nearly 125,000 IOPS when 1,000 desktops are booted simultaneously. This one is more amazing. This is a real-life example of the VMware VAI Xcopy cloning magic that we talked earlier. Time needed to clone many desktops from a template is dependent on the throughput that an array can deliver. Here is an example of what XtemIO can do for VDI. In this example, the GUI is showing that the Xbrick is delivering nearly 45 gigabytes per second throughput when 1,000 desktops are cloned simultaneously from a template. 45 gigabytes per second is an insanely high throughput. The array is able to deliver this throughput at the target site due to XtemIO's in-memory metadata architecture and unique in-memory metadata-based implementation of VAI copy offload API. And finally, consistently low latency is another important criteria for the array to deliver highly responsive, better than physical user experience to all the users all the time at any scale. Here you see that the Xbrick is delivering sub-millisecond latency for 1,000 desktops at steady state. How much data reduction XtemIO can achieve is one of the questions I get in all of my interactions. The mileage varies, but here is the usual guidance we give. Greater than 90% of XtemIO VDI customers fall within this guidance. Examples from customers' production VDI environment. Here the customer is achieving 16:1 deduplication benefits. Here the customer is getting nearly 12:1 data reduction between deduplication and compression. XtemIO has literally hundreds of VDI customers. Here I picked Georgia Tech as they bring out the true value of Citrix and XtemIO together. One area we didn't cover today is GPU virtualization, or vGPU, that solves the most challenging part of VDI, where you are delivering graphics-intensive applications to your users. XenServer from Citrix is the hypervisor that has been the true leader in supporting vGPU use case. And those of you who were at Synergy this May, you have heard Didier Contis from Georgia Tech recounting how XtemIO had been a game changer for his VDI infrastructure, supporting performance-intensive engineering applications like MATLAB, AutoCAD, CATIA in his Synergy 2015 session. A quote from him from that synergy session. Before XtremIO, it took several minutes for his graphics applications to launch. With XtremIO, it came down to just 20-30 seconds. Couple of quick things. VCE vBlock 540 offers a fast path to VDI with its converged appliance approach. It is a single product with a single point of management and single point of support with all servers, networking, and XtremIO pre-integrated, pre-engineered, and tested at factory for a complete turnkey VDI solution that is truly plug and play. EMC offers the broad and complete VDI solution, not just XtremIO. We use XtremIO for VM data and Isilon and VNX for user data, user file share, coupled with complete BC, DR, and security solutions from EMC portfolio. Finally, a quick note about special XtremIO programs that are relevant for desktop virtualization use case. We offer the same maintenance pricing per year for a full 7 years. This is very uncommon in storage industry. We have 7-year SSD endurance guarantee as well as 3-year money-back warranty. To conclude, the XtremIO value proposition has been proven again and again in over 2.5 million desktops already deployed on XtremIO. XtremIO delivers an unparalleled user experience, think similar to MacBook Air performance and speed, for all users, for all desktop types at enterprise scale all the time. The deployment model is very cost effective, a lower cost than having physical desktops while having an amazing end user experience and a quick deployment time, leading to a successful VDI project from pilot to full scale. XtremIO is really a true game changer for VDI. These are your next steps. We are available for demonstrations, deep dive discussions, analysis, all of those things. We also have a lot of assets available online for your further research. Thanks for your time today. Now, I think we are going to open the line to take a couple of questions with the time we have remaining. And if we do not get to your questions live or we haven't already answered those online, we are going to follow up with you via email post this session.
Thank you so much, Chandramoy. That was a wonderful presentation and demos. We are indeed short of time, and I'll just quickly run through a couple of more questions, and Chandramoy, we can take a call how many we want to take. So one thing that has come here, our target, there's a concern raised by an attendee here. Our target VDI environment is small, around 400 to 500 desktops. Shall we consider a powerful all-flash array like XtremIO?
So I'll give you a quick answer to that one. So we focused on VDI in the session today, but literally the value proposition of XtremIO is consolidation of a lot of the workloads, truly transforming all of the applications that you are running for your data center. So consider using XtremIO for mixed workloads in addition to VDI, such as database production, dev test, reporting consolidation, and your virtual server application. So that's the short answer.
All right, thanks for that. Another connected question, what's your take of hyper-converged appliances for VDI where compute and storage are within a single node?
That's a very good question. A hyper-converged appliance is essentially a server which is doing at least two primary functions. It's acting as a storage controller and hosting an application like VDI. So to begin with, you don't get desktop density on a hyper-converged appliance node like a regular server that it essentially is. Typically, you get 1/3 of a server desktop density on a hyper-converged appliance node. Then you'd need at least 3 hyper-converged appliance nodes to have any redundancy at all. Okay, so the economics really don't work when you start looking into details compared to a server and SAN-based VDI solution. But the real deal breaker to me is the performance consistency. Okay, if the hyper-converged appliance nodes reserve dedicated CPU cycles for storage controller functions, then potentially you have your server underutilized coupled with low number of desktops per node. Now, on the flip side, if you do not do CPU reservation for your storage controller function, then you get inconsistent performance depending on peaks and valleys of the storage controller function in the hyper-converged appliance nodes that are running VDI as well. Our customers really value getting consistently great application response time in a snappy desktop, potentially better than their original physical one. XtremIO is really the only platform that can deliver uncompromising user experience at scale all the time for any user type. Okay.
We are stretched on time, Chandramohan. Just one more question. Flash is very expensive. How do we justify the capex?
Okay, Flash is expensive. However, you have to take a look at the bigger picture. As I was talking and demonstrating to you, taking VDI as an example, you can get anywhere between 10:1 to 20:1 data reduction ratios. You can actually consolidate a lot of your other workloads on a very small capacity footprint. Like, for example, our starter 5 terabyte Xbrick node. So if you look at the end of the day, dollar per desktop for your storage, we definitely offer better than anybody else out in the market. I would say like it's definitely less than $100 per desktop by a significant margin. And so even if like it's costly for an array perspective, it might appear that. However, whatever you can consolidate is actually much more effective than the raw dollar per gigabyte that you might be looking at in the first place.
Hey, thanks Chandramohan and the EMC team for who've been supporting the backend, for making this fantastic presentation and demo and sharing your knowledge with us. I think we are totally stretched our time, and now we need to conclude. There are another question that has been asked is about the slides and the recording. Yes, we will send across the recording and the presentation within a day or two to your registered email ID. With that said, we are about to end today's webinar, and most importantly, I would like to thank each one of you attendees for making it today for our webinar in the Citrix Ready Technical Webinar Series. And that concludes our broadcast. Thank you.